If you stuck through part 1 and part 2, we're at the end. This is part 3. Thank you for hanging in there. If you haven't had a chance, go and check out part 1 and part 2 for a full review of our proportions and our unit rates and our ratios. Now, welcome to episode 3, Catching Slope. Okay. Alright. Now, I talked about the fact that proportional relationships have a constant rate. They go up the same amount, they go down the same amount, they all are equal to the same thing, so they have this constant change that they make. For example, if you have cost and you have tickets, we want to put this into a table. You would have 2 over 20, you would have 3 over 30, 4 over 40. You get the idea. Our constant rate is that if we put, again, this is x, this is y. I'm going to use this y over x to help me out. Y over x is going to be 2 over 20, 30 over 3, 40 over 4, which was 20 over 2, my mistake. You're going to end up with this constant rate of 10. Each time you go up by 1 ticket, this is completely backwards, but you understand what I meant to say. This is cost, this is tickets. That would be a little bit interesting. Take 20 tickets for $2. Rate of 10. So this 10 over 1 that we're getting, this constant change, in math we call this my constant rate of change. And if I ask you to find the constant rate of change, all I'm asking you to do is find my y over x among proportional relationships and then tell it to me in a full sentence. So if this is tickets and this is cost, and we know that we have 10 over 1, $10, 1 ticket, I want you to tell me my constant rate of change, so you'll put a full sentence that says the constant rate of change. The change every single time is that every time you go up by 1 ticket, it costs $10, or to put it in words that aren't as awkward, each ticket costs $10. That is a constant rate of change every time. 1 ticket. You need to simplify it all the way down first. The constant rate of change is not for every 2 tickets we buy, it goes up $20. No, it's for every single time. 1 ticket, it goes up $10. That full sentence is my constant rate of change. $10 per ticket, which also relates back to $10 per ticket per unit, relates back to the first video that we first talked about, unit rate. It all comes full circle. Let's get to slope. Now, if you graph, they're yawning with excitement. If you graph a proportional relationship, it's going to have a constant rate of change. Let's go graph the table that we just talked about. Here we have our tickets. Here we have our cost. I'm going to go 10, 20, 30, 40. So 10, 20, 30, 40. And I'm going to have 1, 2, 3, 4, 5, 6. So 1 ticket, 2, 3, 4, 5, 6. So, two tickets, $20. 3 tickets, $30. 4 tickets, $40. Remember, you're going to graph the entire grid, not just the points. We have a constant rate of change. Every time we go up a ticket, we go up $10. This rate of change between 2 points, here we have points on a graph now, that's what these are. These points on a line, we have a line. These points on the line, this rate of change between 2 points is called slope. You've already found it in word form, but when it's on a graph between 2 points, I'll put between 2 points, that's when we call it slope. Now, if I ask you to find the slope on a graph, you could count it. You could say how much are we going up and how much are we going over, because we know that slope as m, because slope is m, is rise over run. That is how we write slope. Our rise being our y, our run being our x. Slope is rise over run. So if you want to write the slope, you're going to write how much are you going up and how much are you going over. We're going up 10 each time. The slope equals up 10 and over 1. Our slope is 10. This is the steepness of a line with 10 on this graph. Now, if you didn't have a graph and I just gave you 2 points, you could also find slope by using our formula. For example, if I said x and y, and I said 20 to 2, 30 to 3, 40 to 4, you're going to pick 2 points and you're going to find the slope by using the formula. Formula is m equals y2 minus y1 over x2 minus x1. And you're looking at me like y2, y1, x2, x1, these sounds like movie titles of really weird things. I promise these are not sequels. These relate to math. Well, x2 is also the second x, not the point. We have a point right here. We have a point right here. This is point 1. This is point 2. We have an x, we have a y. Take your second y, which is 3. Subtract your first one, which is 2. Put that over. Remember, y always goes on top. That's an important thing to remember, and you may see that on your test. Bug in my eye. Over, here we have our first x, our second x. 30 minus 20. When we simplify this down, we're going to end up with 1 over 10. But remember, it's rise over run. So if we were to graph this relationship, every time we go up 1, we would go over 10. Rise over run. This is backwards from the one that I drew on the board a minute ago.
Okay.
The one that I drew on the board a minute ago had the this guy be your 1 through 5, and this guy be your 10s. So if the one I drew on the board a minute ago had the x-axis be 1, 2, 3, 4, and the y-axis be 10, 20, 30, 40, which is why this is backwards. Now, that's another way you can find slope, is using our slope formula. Lastly, if your slope has a negative, let's say your slope is -3. If your slope is negative, that negative always applies to the y. We know that -3, written as a fraction, is -3 over 1. So that slope always applies to the y, which is rise over run, up or down. So, if we were to graph a slope of -3, it would be -3 over 1. Meaning that you would go down 3 and you would go over 1. So on a slope, you would count down, from your first point, you would go down 3, 1, 2, 3, and over 1, and that's where your next line would be. Same thing, 1, 2, 3, over 1, that's where your next line would be. And with the slope, you can graph lines for, you can graph points for as long as you want, and they're all going to fall along that line. Good luck.